Okay, we're going to go on to 4.4. This is trig functions of any angle. Okay, so we're not just going on the unit circle now, we're doing any angle. So if you notice on this circle here, this is the unit circle with the unit of 1. But the same points can apply if it's similar triangles. Notice that this triangle here is similar to this triangle here. Okay, that means they have the same types of ratios and so forth, so we can expect similar results. All right, so here's the basic information just like we had before. I'm not going to go over it again, but the only difference here is instead of saying opposite and adjacent, we're using and hypotenuse, we're using x, y, and r. Then that represents any triangle. All right. One of the important things, and I kind of briefly talked about it in the other video, is knowing which trig functions are positive and negative in the various quadrants. So if we're in quadrant 1, you will see that all of the trig functions will be positive. If we're in quadrant 2, I want you to notice that only sine is positive. And if you think about this, let's look at cosine. If you remember, cosine is the same thing as x. So if I'm here and I go back, x is going to be negative, therefore cosine will be negative. However, if I go up to be in this second quadrant, y is positive and therefore sine is positive. Now tangent, remember, it's opposite over adjacent, which means if one of the trig functions is positive and the other is negative, then you're going to have a negative. So here we have sine being positive and its reciprocal. Over here, since they're both negative, x and y, that makes tangent positive and the other two negative. And over here, we have cosine that's positive because that's our x value going forward, but sine is negative and so is tangent. So the easiest way to remember all of these is by saying all are positive here, okay? Sine is positive here, tangent is positive, and then over here is cosine is positive. So each of these trig functions has two positive. Sine is positive here and here, tangent is positive here and here, and then cosine is positive here and here. All the other trig functions in these quadrants, in these three quadrants, are all negative. Okay, only the reciprocals are also positive. Here's another way that you can think about it. It says all students take calculus. Okay, this actually helped some of my students in a previous class or a previous semester. So, and they said, oh, you should just definitely explain this because that helped me a lot. So all students, all sine, take calculus, tangent, cosine. So this is a little, a simpler way of remembering which is positive in which quadrants. All right, let's go on to the next page. Okay. All right, over here it says, now we're going to let this point be a point on the terminal side of an angle in a center position. Find the sine and cotangent theta. All right, first thing we're going to do, and I'm always going to recommend this, no matter where you're at, is draw your triangle. Okay, so here's my coordinate system. 20 is going to be positive. 21 is y is going to be negative. So we're going to be in quadrant 4. Okay, all I'm going to do is draw my regular triangle. Here's going to be my theta, okay? And then I'm going to do 20. This is 20, okay? Negative 21, that's going to be over here. Now, in order for us to find sine, we're going to need the hypotenuse, or the radius as well. So we're going to use Pythagorean's identity, or theorem, to solve for that. So I'm going to do 20 squared plus negative 21 squared equals r squared, okay? 20 squared plus negative 21 squared is going to equal 841, which is r squared. So now I'm going to take the square root of that, and I can see that r is equal to 29. Okay, remember we're using a positive here. your radius or your hypotenuse will always be positive in this cases. Now I'll show you what it means to be negative in another unit. Okay, so now that I have this as 29, let's go ahead and find sine. Sine theta. Well, if I'm looking here, sine is opposite, which is negative 21, over hypotenuse, which is 29. Cotangent. If you remember, cotangent is the reciprocal of tangent. So cotangent is going to be adjacent over opposite. So adjacent is going to be 20. Opposite is going to be negative 21. Okay, and does this match our trig functions for over here? Well, yes, the only thing we expect to be positive in quadrant 4 is cosine. So sine and cotangent should be negative, and here they are. All right. Okay, next part we're going to do is we're going to go ahead and talk about what happens when our angles are actually on the x-axis or on the y-axis. Okay, so it says find sine, cosine, and tangent for the angle of 90. So all I'm going to do is put my point up here. If you remember, this point is 0, 1. Okay, this is my x, this is my y. All right, so if we're looking for sine of 90 degrees, I'm going to say sine is y over r. So this is going to be y over r. Well, if you look at a circle here, the r would be the distance between the origin and that point. So here, r is going to be equal to 1. So y is 1, r is 1. So the answer here would be sine of 90 degrees is equal to 1. Okay, let's look at the next one. Cosine. So cosine of 90 degrees is going to be x over r. Well, what is x? X is 0, r is 1. So cosine of 90 degrees will be 0. Okay, and then let's go ahead and do tangent. I'll do tangent over here. Tangent is going to be, tangent of 90 degrees is going to be y over x. Y is 1, x is 0, and anytime you have a 0 in the denominator, it's undefined. Let me use the calculator to make sure all of these things are true. Make sure you're on degree mode, which I am, and now I'm going to do sine of 90 degrees. There's my 1, there's my 1. Let's do cosine of 90 degrees, 0, 0. Tangent of 90 degrees, domain error, undefined. All right, perfect. So let's go ahead and move on. Now, a lot of people get reference angles and coterminal angles confused. They are completely different. Remember, coterminal angles means the exact same angle. Reference angles is always going to be the angle between the line and the x-axis. So it's going to, the equation to figure that out is going to vary depending on which quadrant you're on. If you're in quadrant 1, your reference angle will be the angle that you're talking about as long as it's in standard form. Quadrant 2, you would use this equation. This is our theta that's given, but the reference angle will be from the line to the x-axis. So we wouldn't go from here to here. It has to be an angle less than 90 degrees. So if we're in quadrant 2, we're going to have to say, oh, well, if this line is 180 degrees, I'm going to have to subtract the angle that I'm given if I'm given an angle in quadrant 2. That is going to be our reference angle here. Now, if you're in quadrant 3, you're going to be given an angle between 180 and 270 degrees, but you only want the angle between the line and the x-axis. So we wouldn't go all the way back. We would have to make sure it's less than 90 degrees. So I would go from here to here. Well, in order for me to get that reference angle, I'm going to have to subtract quadrants 1 and 2, which is 180 degrees. Okay, this is for radians, so they're very, very similar. And for quadrant 4, if I'm given an angle between 270 and 360, I am going to say, well, if the entire completion is 360 degrees, I'm going to subtract the angle that I'm given, because that will give me the angle between the line and the x-axis. Okay, so these are reference angles, and this is really, really, really important. We're going to be using it throughout the semester, but please don't get it confused with coterminal angles. All right, so find the reference angle for the given angle. Okay, well, let's go ahead and draw this angle. This is going to be an angle in quadrant 3. It's greater than 180 but less than 270. So I'm going to go ahead and draw an angle in quadrant 3. This is going to be 225. So I'm going to say 225 minus 180 degrees. Use your calculator and you find out that the reference angle is 45 degrees. Okay, for 2, 11 over 6 pi. Now, a lot of people have a little bit of problems remembering what quadrant we're in when we're doing this. Here's an easy way to remember. If I do 11 divided by 6, that will give me 1.83. And if we remember our pi, this is going to be 1 full pi. Okay, this is 2 full pies. So that makes this half a pi. This is 1 pi. This is 1.5 pi, and this is 2 pi. So when I'm trying to determine what quadrant this is in, I'm going to look at the 1.8. Well, 1.8 is definitely more than 1.5, but less than 2. So we're looking at an angle in quadrant 4. Okay, so the equation for that to find our reference angle is the angle we're looking for is this angle right here. In fact, what I'm going to go ahead and do is I'm going to go ahead and show the reference angle. This is going to be our reference angle. Okay, this is going to be our reference angle here. So in order for me to find out that pink reference angle, I'm going to say, well, it's going to be 2 pi minus 11 pi over 6. I already have that number here, so I'm going to say 2 minus second answer. That will give me that, and I'm going to change it back into a fraction. So I can say this answer is going to be pi over 6. Okay, that's going to be my reference angle for that problem. Going on to the third problem, notice you have a negative here, which means that this is not in standard form. I always recommend to go ahead and put it in standard form just to make it a little bit easier. So how do we put it in standard form? Add 2 pi. Okay, always add 2 pi to get the standard form. So I'm going to do negative 2 divided by 3, and I'm going to add 2. Okay, that will give me the 1.3. And we're going to use, since we're using radians, I'm basically going to be using the same chart here. So 1.3 is more than 1 but less than 1.5. So we're going to be in quadrant 3 for this angle. I'm going to go ahead and draw it out here just like that. And then remember, our reference angle is just the angle between the line and the x-axis. So that's the part that I'm looking for, okay, the pink. So in order to get this, I'm going to actually start with the angle that I'm given, which I'm going to go ahead and convert this into a fraction so I can see what it is. This is going to be an improper fraction, 4/3. I'm going to put here 4/3 pi. Okay, so I'm going to start with the standard angle, 4 pi over 3, and I'm going to subtract pi, which is the part that's not shaded. So if I look back at the unit circle, I'm going to say 180 degrees is equal to pi. Here it is here. So when I subtract that, you will see that that equals pi over 3. Okay, so that's going to be our answer for number 3. Going on to number 4, again, this angle is more than your standard angle. It's greater than 360. I find it easiest if you always take it back to standard angle. So 390 minus 360, that's 1 full rotation. You're going to get 30 degrees. If you're in 30 degrees, you're in quadrant 1, then your reference angle will just be 30 degrees. Okay, because you're already in quadrant 1. So quadrant 1 is like the easiest as long as it's in standard form. Okay, we are done with that section. So here it's saying what we're going to do is we're going to evaluate the trig functions using the reference angles, okay? What I'm going to do instead, or slightly different, is I'm going to go ahead and just use our unit circle. So here it's going to say evaluate each of these sections. So let's go to cosine of 135. Look for 135. Here it is. Cosine of 135 is x. So the answer here would be negative square root of 2 over 2. So negative square root of 2 over 2. Okay, that's it. Let's go on to the next one. Sine of 240. So I'm going to go over here, look for 240. Sine is referring to our y value, and y here is negative square root of 3 over 2. So negative square root of 3 over 2. It really is that simple. It's evaluating the functions at that particular angle. Okay? Number 6, tangent 5 pi over 6. 5 pi over 6, tangent. Do you remember what tangent is? Tangent is y over x. So here you're going to have 1 over negative square root of 3. Never leave it with a irrational denominator. You have to rationalize it. So I'm going to go ahead and do that real quick. And you get negative square root of 3 over 3. Don't forget the negative. That's going to be a major problem if you forget that, because then a lot of other things will build off that. And if you have the wrong sign, you're going to have everything else wrong in the future. All right, let's go on to the next one. Number 7. Number 7 is negative 11 pi over 6. This is not in standard form. So what we're going to have to do is go ahead and make it into standard form. It's going to be the easiest way to do this one. So I'm going to go ahead and put here cosecant 11 pi over 6. And you're going to add 2 pi because you want it to be a number between 0 and 2. Let's go ahead and use the calculator for this. Negative 11 over 6, okay? And then, and then we're going to add 2. Okay, there you go. Second PRB, and we got pi over 6. So these two angles are exactly the same, this one and this one, and it leads to the exact same location. So now I can go to my unit circle and say, all right, cosecant pi over 6, here's pi over 6. Cosecant is the reciprocal, or you flip it with sine. This is our sine, y is sine, so you're going to flip that number. And this is, in this case, will just be 2. It's 2 over 1, but you can just write 2. Okay, so let's go ahead and do a few more of these. Again, not in standard form, so I'm going to do cotangent 540 minus 360, and let's see if that gets us what we're looking for. 540 minus 360, it's 180. Yes, it does. It falls between 0 and 360. So I'm going to come over here. Cotangent of 180, that's going to be x over y. So we have negative 1 over 0. Remember, this is undefined. Anytime you have the 0 in the denominator, undefined. Okay. Next one. Secant 5 pi over 3. If I go to the, here I see 5 pi over 3. Here it is. Secant is the reciprocal, or the flipped version of cosine. Cosine is 1/2. So if you flip it, you get 2 for secant. Okay, that's the answer for that one. All right. You should be practicing these on your worksheets, and like I said before, I'm going to be trying to make the videos after I do all the lecture notes. Okay, let's go on to the next page. Here it says, find two angles between 0 and 360 where cosine is negative square root of 3 over 2. Now, what we're trying to solve for here is theta, which is next to your trig function. Okay, so let's go back and let's refresh. Cosine is our x value. If our x is negative, that means we're talking about quadrants 2 and quadrant 3. Because in order to be in these quadrants, x is going to have to be negative. Y can be positive, y can be negative, but x is the one that's negative. So what we're going to do is just look for this value in quadrant 2 first. Where is negative square root of 3 over 2? Well, it's right here. Over here, it's telling us it needs to be a degree. So when we're choosing which one we use, we have to go with the information that is given. So if it's asking us for degrees, we're going to go ahead and say, well, that can be 150 degrees. Or theta can equal, well, let's go to quadrant 3, where cosine is also negative, and we're going to say, oh, it can also equal 210 degrees. Okay, because remember, this is going to be our x value. So this is our x, this is our x. These are the same values. These are our correct answers. Hopefully that's not as difficult as you may have thought it to be. Okay, we're going to go ahead and do one more of those, and we're going to be essentially done. Here it says given sine is negative and cosine is negative. We're going to find cotangent and cosine. So let's look at one thing at a time, because you're going to have a lot of problems like this on your homework. Which two quadrants is sine negative? Well, if you remember, sine is the same thing as y, and y has to be negative. Well, in order for y to be negative, it means it has to go down. So if we're going down, sine is negative in quadrants 3, and sine is also negative in quadrant 4. But it also gives us another restriction. It says cosine has to also be negative or less than 0. So cosine is x. If I go into quadrant 4, cosine is actually going to be positive. So I would say cosine is positive here, but the requirements say that cosine has to be negative. Well, cosine is negative in quadrant 3. So we're going to be in quadrant 3. We won't be in quadrant 4. Okay, so let's go ahead and go back and go ahead and find cotangent. Okay, sine opposite hypotenuse. Okay, let's draw our triangle. Here's my theta, opposite square root of 55, hypotenuse is 8. The negative definitely goes to the y value. Okay, can we find our x? Yes, let's use Pythagoras theorem. Okay, so we're going to have x squared plus y squared equals r squared. Okay, x squared plus negative 55 squared equals 8 squared. Okay, this cancels with this, so I have x squared plus 55 equals 64, and subtract. X squared is equal to 9, which means x is equal to 3. Now, it could be a plus or minus 3, but because we're in quadrant 3, it has to be a negative value. So here I'm going to say negative 3. This is why it's important to draw your triangle in the correct quadrant to begin with. Otherwise, you may have chosen x to be positive when clearly here x has to be negative. So let's go ahead and do cotangent. If you remember what cotangent is going to be adjacent over opposite. So here we are going to have negative 3 over negative 3 over negative square root of 55. These two negatives actually make it a positive. Okay, so we're going to have a positive value here. I'm going to go ahead and change that to a plus. Okay, and then again, you don't want to keep the square root of 55 there, so we're going to multiply to make it rationalize. So 3 square root of 55 over 55. That is cotangent of theta. Okay, our other one is cosine. Cosine's a little bit easier. Cosine is going to be adjacent, which is -3 over our hypotenuse, which is 8. Okay, all right, and there you go. You're done with that one. Okay, here are our Pythagorean's identities, reciprocals. Again, everything you need to know. You need to have all of this stuff memorized. I kept it in here because it's going to be a consistent thing. You should go ahead and memorize it. Like I said, I will in a later video or section show you how you can know one and then get the other two fairly easy. Okay, and we have one more here. Let's go ahead and finish off with this one. It says given secant theta is equal to 41 over 40. For an angle in quadrant 4, use the identities to find tangent and sine. Okay, so we don't actually have to use the identities. If you prefer to use the identities, you can. I always find it easier to go ahead and just draw it in the correct quadrant. So I'm going to draw in quadrant 4, and I'm going to go ahead and draw my right triangle, and there's my theta. Okay, so secant, if you remember, is the reciprocal of cosine. So that means that this is our adjacent and this is our hypotenuse. So I'm going to put 41 here and I'm going to put 40 there. So let's go ahead and solve for our y value. It would be x squared plus y squared equals r squared. We're going to use 41 squared, 40 squared plus y squared. Okay, I'm going to use the calculator for this, and I'm just going to go ahead and simplify it. Minus 40 squared, so I'm going to get y squared is equal to, and let's use the calculator. So 41 squared minus 40 squared, that gets me 81. So y has to be equal to plus or minus 9. Because we're in quadrant 4, y has to be negative, so this is going to be assigned a -9 value. So tangent of theta is going to be opposite, -9, over adjacent, which is 40. And sine of theta will be opposite, which is -9, over hypotenuse, which is 41. Okay. So that ends the Unit 1 information. I know it was a lot. Hopefully you can go back and review everything. I will try and post the worksheets next. And let me know if you have any questions.